Lesson 3 of Chapter 11 is on the probability of multiple events. So some vocabulary. We start off by crossing out all the numbers that are not multiples of 8. 74 is not a multiple of 8, neither is 405, but 136 and 48 are both multiples of 8. Number 2, write three numbers that are multiples of both 2 and 9. Well, 18 is a number that's a multiple of those, 36 and 72. 2 and 9 go into all three of those values. So we're going to talk about an event. An event is one or more outcomes from the set of all possible outcomes of an experiment. An example you can see is to roll a number cube. The set of all possible outcomes is 1, 2, 3, 4, 5, 6. The set of outcomes resulting in the event that an even number is rolled is 2, 4, or 6. So some vocabulary, right? The possible event of each experiment. So number 3 says a basket has 5 red balls and 3 blue balls. You pick one ball without looking. So one possible event is that you picked a red ball. Problem number 4, you roll a number cube. One possible event is that an odd number comes up. Going into example 1, it says you select a coin at random from your pocket. You replace the coin and select again. Are your selections independent events? Well, what does it mean to be independent? This right here is what it means to be independent. Selecting the first coin does not affect the possible outcomes of picking the second coin because you replaced the coin. Thus, the two selections are independent of each other. An example of dependent would be to say that you grabbed a quarter out of your pocket, and then if you didn't replace the quarter and you asked yourself, are you just as likely to get a quarter the next time you draw out of your pocket? The answer would be no, because those would be dependent events. So next we're going to talk about the probability of compound events. Compound means that there's more than one thing happening. So the probability of events A and B, key word in mathematics, and means you multiply. As long as these two events are independent, we would say that the probability of A and B is equal to the probability of A times the probability of B. Next we'll talk about the probability of A or B. And next we're going to talk about what it means to be mutually exclusive. Okay, if something is mutually exclusive, is that the two events cannot happen at the same time. So, if A and B are mutually exclusive, which means that A and B cannot happen at the same time, this is how we would calculate the probability of A or B. We would just take the probability of A and we would add the probability of B. But if A and B are not mutually exclusive, which means that they can happen at the same time, this is how we would calculate the probability of A or B. We would take the probability of A, we would add the probability of B, and then we would subtract the probability of A and B. So, an example down below, it says events A and B are independent and mutually exclusive. Again, that means that they cannot happen at the same time. So the probability of A is 3/5, the probability of B is 4/9. True or false? Number 7, the probability of A and B is 4/15. This would be true, because how do we get the probability of A and B? We simply take the probability of A and we multiply by the probability of B, which, since we have both of those, if we take 3/5 and we multiply by 4/9, that gives us 4/15. Number 8 says the probability of A or B is equal to 3/5 plus 4/9 minus 4/5. This is false. And the reason this is false is because these events are mutually exclusive, which means they cannot happen at the same time. So we do not need this part to find the probability of A or B, we would just have to take 3/5 and add 4/9 to get our answer. Moving on to problem 2, it says, at a picnic there are 10 diet drinks, 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you get a regular drink and regular chips? So number 9, define each event. Event A is that you pick a regular drink. Event B is going to be that you pick a regular bag of chips. Number 10 says complete each equation. The probability of A would be the number of regular drinks divided by the number of total drinks, and I believe there are 5 regular drinks and there's 15 total. The probability of B would be the number of regular chips divided by the total number of bags of chips, and I believe that would be 12 over 20. And so then if we go to problem number 11, it says use the justifications at the right to find the probabilities. And we're going to try to find the probability of A and B. And so we're going to take the probability of A, which is 5/15. I'm going to reduce that into 1/3. And then 12/20, which I can reduce into 3/5. And if we multiply each of those, that would give us 1/5, which is the same thing as 0.2 or 20%. Going to problem number 3, more on mutually exclusive events. Again, if events are mutually exclusive, that means they cannot happen at the same time. So it says you roll a number cube. Are the events rolling an even number and rolling a prime number mutually exclusive? Can they happen at the same time? So number 12 says the numbers on the number cube are listed below, 1, 2, 3, 4, 5, 6. Circle the numbers, circle the even numbers. So 2 is even, 4 is even, 6 is even. And then it says underline the prime numbers. Well, the prime numbers are number 2, 3, 4 is not prime, 5 is prime. So we have 3 prime numbers, we have 3 even numbers. And so number 13, are the events mutually exclusive? The answer is no. And why not? Because you can roll an even number and a prime number at the same time. Sorry, you can roll a 2, not a 3. Let's fix that right there. Which is even and prime. Okay. Next, problem number 4, find the probability of mutually exclusive events. Again, if they're mutually exclusive, that means they cannot happen at the same time. It says at your high school, a student can take 1 foreign language each term. They can't take more than that. So 37% of students take Spanish, 15% of students take French, 9% of students take Mandarin Chinese. What is the probability that a student chosen at random is taking Spanish, French, or Chinese? So number 14 says, are the events a student taking Spanish, French, or Chinese, are they mutually exclusive? The answer is yes. Why? Because they can only take 1 foreign language each term. Okay, number 15 says circle the formula you would use to find the probability. Well, we would use this one right here. Because they're mutually exclusive, we just have to add the probability of A to the probability of B to the probability of C. So number 16, we're actually going to find that. And we're going to find the probability of Spanish we're going to add the probability of a French class, and we're going to add the probability of Chinese. And so this would give us 0.37 plus 0.15 plus 0.09, which would give us a result of about 61%. Moving on to problem 5, it says, suppose you reach into the dish at the right and select a token at random. What is the probability that the token is square or red? So let's start with the number of tokens in the dish. There's a total of 9 tokens in the dish. 3 of them are square. 3 of them are red. And the number of tokens that are both red and square is 1. That's going to be important. And so now number 18 says use your answers in this problem to find each probability. Let's see here. The probability of getting a square token is 3 to 9. The probability of getting a red token is 3 to 9. And the probability of getting a square and red token is 1 to 9. So down below number 19, find the probability that the token you select is square or red. We would take the 3/9. We would add the 3/9 and subtract the 1/9 to give us 5/9. And lastly, do we understand this example says the weather forecast for the weekend is 30% chance of rain on Saturday, 70% chance of rain on Sunday. Your friend says that this means there's a 100% chance of rain this weekend. What error did your friend make? So the error that your friend made is that they added the 2 probabilities together. They didn't use this formula. Okay, they just added the probability of A to the probability of B. They didn't subtract the probability of it raining on both days. So lastly, check off the vocabulary words that you understand. We talked about event, we talked about independent events, and we talked about mutually exclusive events. And then on a scale of 0 to 10, let me know how well you understand how to find probabilities of multiple events.